Hey everybody. So what we're going to do in this video here is we're going to walk through the two proportions applet using Exploration 5.2, the Mythbusters study, where they are testing the hypothesis that yawning is contagious. Now, hopefully you've already done the section of the exploration with the cards, where you've shuffled cards together and dealt them into two groups and calculated the proportion of success. So that's doing by hand what we're going to now do with the applet. So what I've done is I've clicked on the TwoProportions applet. You can see it comes preloaded with some data here. That's not data that applies to our study, so it's not helpful to us, so we're going to clear it. Now what we're going to do is we're going to fill in this 2x2 table using the information from the 2x2 table that you filled in question 9. So what we've got here, this group A, this is going to represent the people who saw the yawn seed, and group B is going to represent the people who didn't see the yawn seed. And then when we do these 2x2 tables, the explanatory variable is always going to be in the columns, and then the response variable is always going to be in the rows. And here we're denoting success to be if somebody yawned, and then failure will be if somebody didn't yawn. So let's fill in this data here. So we know that out of the people who saw the yawn seed, 11 people yawned. And we know that we had 34 people in that group, so that means we had 23 failures. And in group B, the people who didn't see the yawn seed, we had 3 yawners and 13 people who didn't yawn. All right, so now our total here is 50, so that's great. That's our sample size. Everything's going well. So we're going to hit Use Table, and this plot now has changed a little bit. So we have our two groups, Group A and Group B. Now this is a segmented bar chart. And the segmented bar chart, we use that when we are comparing two groups and we're comparing the proportions within those two groups. So each of these two columns is going to sum to 100. And this lower part here, this is our proportion of success within each of these two groups. And remember, we're denoting success as whether somebody yawned, and failures if they didn't yawn. So group A, this is the people who saw the yawn seed, and group B is people who didn't see the yawn seed. And now, one other important piece of information that you can get here is this observed difference of success. So this is the proportion of success from group A, and then we've subtracted the proportion of success from group B, and we get this difference of 0.136. And you can see it's specified right here, group A minus group B. And that's the order that we want things to be in, so we're good there. And now, let's see, a few other things on this applet. There's a bunch more stuff down here. We could have kind of cheated and used this yawning study button, but it's important to see how this is all set up. Now, this section here that we just filled in, this data is fixed. We've observed this data. This is not going to change. Now, what we want to do is we want to shuffle. We're going to hit Show Shuffle Options. And when I say we're going to shuffle, we're going to run a simulation. So remember, when we're doing hypothesis testing, we need a null distribution to compare things against, or to compare what we observed against to see if what we saw was unusual or not. So in this study, our null hypothesis is that there's no difference between the two groups, that each group will have approximately the same proportion of people who yawn, whether they see the yawn seed or not. So if there's no difference between these two groups, then it shouldn't matter what group people belong to. And what our null hypothesis is saying is that people are going to yawn no matter what. Like if they were going they were going to yawn regardless whether they saw the seed or not. So this is the null hypothesis that we're working under. And this is why we can take all of our cards that represent people and we can shuffle them all together and deal them into new groups. It's because we're saying that the yawn seed under the null hypothesis does nothing to affect whether or not someone yawns. So we're going to hit this Show Shuffle Options. I'm going to slide this over just a little bit. So what you first see when you click Show Shuffle Options is this is your actual data. So group A, remember, is representing people who saw the yawn seed, and group B is representing people who didn't see the yawn seed. And in group A, these blue cards are going to represent our yawners. So we have 11 in group A and 3 in group B. And one thing that's kind of nifty with this simulation or with this particular applet is it puts this blue bar across all the cards that start in group A. And it's not super important, but it's kind of interesting to see where these cards move around to in the course of being shuffled and redealt. So we're going to start with just one shuffle. This is going to be very similar to what you did with the cards by hand. So the applet shuffles all 50 cards together, and then it deals 34 cards into Group A, because that's how many we started with in Group A. And then it deals 16 cards into Group B, because Group B started with 16 people. So in Group A, with this one shuffle, we wound up with 10 yawners in Group A and 4 yawners in Group B. And so you can see the blue bars have moved around a little bit. So all the blue bars are just representing is the cards that started in Group A. So like I said, it's not super important, but it's just kind of nifty to see where these cards go. Lets you, interesting to see how the applet shuffles them. So now we have this plot over here on the right. You can see we have one total shuffle. We have one blue box. So this box is representing the difference in proportions between the two groups, and it's maintaining the same order of subtraction that we specified over here. So this is a positive number, and we can see this blue here, most recent shuffle difference in proportions, is 0.044. So that's saying that Group A had a slightly higher proportion of success than Group B. Now this number will change depending on the shuffle. So again, remember the data over on the left side of this line here, this center line, this is our original data. It's fixed. It's not going to change. The data on the left side over here is going to change because these are simulations. So now let's run our standard 1,000+ simulations. You hit shuffle and we have our null distribution over here. So this is our most recent shuffle, this chunk here. So in our last shuffle that we ran, we got 9 yawners in the group of people who saw the yawn seed and 5 yawners in the group who didn't see the yawn seed. And the results of this particular shuffle correspond to this blue bar right there. Now you can click around on this null distribution and you can see the simulation changes. So when you click over here, what it does is it brings up the simulation that corresponds with that particular result. So it's kind of a nifty thing to see what that actually looks like. To get those results, you can actually see what the simulation would look like. So now that we have our null distribution, now we can continue on with our hypothesis test the same way that we usually do. So the alternative hypothesis in this case is that people who saw the yawn seed, the proportion who yawn will be higher than the proportion of people who yawn without seeing the yawn seed. So it's already set up with the right alternative hypothesis. So in this box here, we're going to put our observed result. So not this. Remember, this just corresponds to this shuffle. We're going to put this value in, our observed. So 0.136. And we'll hit count. All right, and this should look kind of familiar. So this red number here, this is our p-value. So it's saying out of this 1,001 shuffles, 260 times we observed a difference in proportions of 0.136 or greater. So we have a p-value of 0.2597. That is not strong evidence against our null. We would conclude that there is not enough evidence to show that not enough evidence to show that the proportion of people who see a yawn seed is greater than the proportion of people who don't.